Hi, in this video I'm going to explain and discuss some examples on the applications of trigonometry. So we'll start with number 4. An observer at the top of a 40-meter high building observes that the angle of depression of the parked car is 78 degrees. How far from the base of the building is the car parked? Essential to problem solving is how you visualize what is given or what are the information given in the problem. So to do this, we have to take it sentence by sentence and try to sketch and draw so that we could see what's happening. It says an observer, so let's focus on number 4, an observer at the top of a 40-meter high building. So there is an observer on the top of a building. So let's say this is the building. You don't need to draw like a person there, but we can just assume that that person is a single point. Okay. Anyway, whatever we are doing here are just estimates of the reality. Okay, so we know that the height of the building is 40 meters. So we label this as 40 meters. And then it says that the angle of depression of the car park is 78 degrees. Okay, so you need to know what does it mean when we say angle of depression. In concept, angle of depression is measured. So if, for example, this is the observer and there's another object down here, if the observer is looking at this object, so let's call this the observer and this is the object, say object A. So this line is the line of sight. Okay, so when you look, or when the observer is looking at this object, this is the line of sight. The angle of depression, so the angle of depression is measured from the horizontal down to the line of sight. So this is the angle of depression. Okay, so in our case, in number 4, or problem number 4, there is a car parked somewhere here. Okay, so that's the car parked somewhere here. So the observer is looking at the car. And it says that the angle of depression is 78 degrees. So from the horizontal, so the angle of depression is the angle from that horizontal line to the line of sight. And in this case, it is 78 degrees. Okay, so once you have that, try to create a triangle out of your drawing. Remember, this is an application of trigonometry, and trigonometry is all about triangles. There are 2 triangles that I can draw from here. So one triangle is this triangle, as you can see, this triangle. And the other triangle is if I make a line on this side. Okay, now suppose I will use the triangle on the upper side. So I will be using this triangle. So if the building is a 40-meter high building, and from the figure you can actually see that this height on this side is actually the same at this side. So if this is 40, and then this must be 40. Okay. Now, the question is, how far from the base of the building is the car parked? So we want to find this. This is what we need to find. Okay, so let this be x. Now, if these two sides are the same, then, and this is a rectangle, or maybe a square, we still don't know. It's a rectangle, so this side x must be equal to this side, so this is a measure also of x. Okay, remember what we are going to take, or what the triangles that we are going to take will be the triangle on the upper side. So I'll recreate the triangle. So this is 40 meters, and this is x, and this is 78 degrees. This is always 90 degrees. Okay, because this is from the ground, or the building is in the ground, it is assumed to be 90 degrees. Okay. Now, once you have the triangle, you have the information there, you have the unknown. The next thing that you need to do is to decide what equation can you form in this triangle. There are three options. It's either you use the saw, the ka, and the towa. The saw is for the sine, the ka is for the cosine, and the towa is for the tangent. Okay? So means if I get any, or sine of any angle, say theta, all I have to do is to get the measure of the opposite side over the h. The h is the hypotenuse of the triangle. And the hypotenuse of a triangle, by the way, just in case you're not familiar with it, it's the side opposite the 90 degrees. This is the hypotenuse. Okay, for cosine, so if I will have to find cosine of theta, so from the ka, a means adjacent, and then h is also hypotenuse. And finally, if I want to use tangent theta means opposite over adjacent. This O and A, opposite over the adjacent. It's the opposite side over the adjacent. Now, going back to the triangle, so this is our triangle. So, always look at your angle. Okay, so this is the angle 78. With respect to this angle, this side 40 is the opposite side of the angle. This side x is the adjacent side of the angle. So if I have to choose between, or if I have to choose, if it's a sine, a cosine, and a tangent, all I have to do is to recognize which sides are given, or at least related to the problem we are solving. So since I have opposite and adjacent, then my equation should be a tangent equation. So tangent theta, the angle theta is 78 degrees, must be equal to the opposite, which is 40 over the value of x. This equation, if I perform operations, this will become x tangent 78 equals 40. Okay, you can simply look at it. It's like you're cross multiplying tangent 78 and x. And then finally, since what we want is the value of the x, we need to divide this by tangent of 78 degrees. So tangent of 78 degrees. And all you have to do is to compute for the value. So we have 40. So if you have a calculator, you get your calculator. So 40 divided by tangent of 78. If you solve for that, it should be 8.50. So the final value of x is 8.50. So let's write that down. So we have x is equal to 8.50, and this is in meters. Okay, so the distance of the car from the base of the building is 8.50. Okay, so that's how you solve a problem involving angle of depression. If you will encounter problems on angle of elevation, the idea is basically the same. Okay, so I'll be explaining the other problems in another video. So for now, I hope you understand how I solve the problem on this example. Okay, that's it.